One of the big questions that's been asked around the internet is how you can go about coding in English and what programming language will allow us to program in English and why one doesn't exist. And to demystify things, just to start the video off right now, there is a language that allows you to code in English, and it's the oldest coding language out there, and that is law. Without getting too deep into the weeds with Aristotelian objects, I'm going to walk you through the similarities between law and software programming and how they're used pretty much the same way, and they basically do the same thing. So if you feel uncomfortable with learning the new terminology of a computer programming language, you may want to consider law school. I'm going to start off with software coding, and I'm going to use some fake Python-ish code to kind of explain how this all works and walk through some of the terms that are in this so that you can kind of understand the parallels between law and computer programming. In front of us right now, we have the creation of a class called car in a video game. And with most software scripts, you want to be able to define what you're dealing with ahead of time. That way, anytime that you want to have a car do something, then you just call upon the car and you don't have to spell out all of the different information that is contained within the car every single time. So you can see here, a car would have a function on, or a method, depending on which computer programming language you're using, called accelerate. And to do acceleration, you would have velocity as defined by a math formula. I'm actually kind of older school, so I think of things in terms of PlayStation 2, Grand Theft Auto video games. The longer you hold down the X button, the more that acceleration starts up, and of course it's an S curve, so the acceleration starts slow, speeds up, and then tapers off when you're near the top speed of your vehicle in that video game. And of course you would be able to do that in law now that everything's controlled by computers in the real world. The function to decelerate, this has to do with braking, and this is going to be defined by a formula that has a different S curve, where of course it slows down very little in the beginning and then decelerates faster, and then towards the base you're going to define how the vehicle stops towards the end of your deceleration. Constants, of course, with a car. When you're declaring a class in a video game, you of course have to say that it has 4 wheels, and you obviously would need to call in different visual assets when you're creating the video game to define exactly what that looks like as you go through the process. You could even define things like the horn and how loud that is. I just have 97.3 decibels up on the screen right now. That's relatively loud, but it won't blast your ears out, and of course that will be controlled by whatever amplifier you've got and speakers and whatnot. And then as far as variables, in a video game it becomes really important how many seats are in the car. If you're playing Grand Theft Auto and you've got like the Banshee, you're not going to be able to carry 3 other passengers if that's what the mission calls for, so you have to get a car based upon the number of seats that are in it. Max distance, of course, in the GTA video games, you don't have to buy fuel, but in some of them you do have to buy food, so that might depend on video game to video game whether or not you have to buy fuel for a vehicle. And then variable size, again, the size could be connected to how many seats there are, but if you have like a giant 18-wheel truck, it might only take 2 passengers, whereas a van, which is a bit smaller, might take 6, or a sports car, which is smaller than that, would take 2. So you define all of those different things in the video game. Now, to show how this relates to law, I'm going to show you a legal code or a legal type definition where you'll see a lot of parallels in how these different objects are actually defined. In a legal code, you would have a statute number, so Senate Bill XYZ, something like that. In that Senate bill, or in whatever statute is passed, it will include a section called "A car is defined by vehicle with 4 wheels, capable of transporting at least 1 person and or cargo." In this case, we're actually including pickup trucks as a car. Uses an internal engine fueled by diesel, gasoline, ethanol, or electricity. And then has enough power or capacity to drive at least 20 miles without refueling. And I'm going to add a last one here. Can attain a maximum speed of 15 miles per hour. What would be the importance of defining a car legally? One of the major ones would be passing safety regulations. When you have something like a maximum speed, if you're going to require seatbelts, you might not require seatbelts for a vehicle that can go over 15 miles per hour or can travel less than 20 miles. Especially when you look at something like this, something that might fit in this category would be something like a tractor. And you don't want to necessarily put safety equipment on a tractor that's on a car because you might disproportionately affect another industry like farming if you just lump all tractors in with other cars. I think you can see here there are some parallels in here with the class that we have defined above in fake Python code, which is vehicle with four wheels. We have vehicle with four wheels. You have acceleration and deceleration functions. This might not be something that's defined in the object necessarily for law, but you might want to define how quickly a car can accelerate and decelerate for the purposes of safety, especially when you're dealing with something like tires. Tires have to meet certain traction requirements because if you can't brake within a certain period of time, especially on rainy days, you can create a lot of accidents. The acceleration and deceleration functions defined in the video game might not be as important for declaring the object in law. Those different things are equally important to the law because you might write a statute that says something along the lines of a car as defined by statute XX article YY section ZZ, and then you would have this be in statute XX SB whatever article number, article 3 or whatever, and then section ZZ. You can always reference this definition in the future on all future legislation, which allows you to manage this, again, very similar to coding, allows you to manage this object with the way that the law is written. And again, with software, the reason why you want to define this class up front is because then you can always call on the class car in the future, and you don't have to define what a car is every single time you want to create a Banshee or whatever type of vehicle you're trying to call up in a video game as you're actually going through and coding it. With cars, you have a certain set of safety regulations, and then you have other things which are vehicles without four tires or four wheels. That becomes a little bit complicated to administer because if you want to pass a law that says a vehicle must decelerate within XX feet under these conditions, you're not impacting motorcycles, which have only two tires or two wheels that you actually drive on. But you don't want to necessarily have to list out every single time you pass a new law, motorcycles, pickup trucks, semis, all the different vehicles and how quickly they want to stop. You need a different type of class so you can define a different type of object. To do this, I'm going to pull up a different definition here, which has a lot of overlap with our definition of car, and that is a definition for automobile. And in this case, with the law, you would have a vehicle with at least one wheel, capable of transporting at least one person or cargo, uses internal combustion engine or electricity. Again, all of this is very similar, can exceed 15 miles an hour. Everything's exactly the same, except, of course, this first line item here. And this would be statute XX, article YY, section ZZ, automobile point 1. This is important because if, say, the government issued a fine on someone who was creating tractors that went less than 15 miles per hour, they could go into court and they could say 0.5 exempts us from this and this fine is invalid, and then they could fight that within court. And you can see everything here is very similar, and you can have the car be defined as a car is an automobile with 4 wheels. And now your legal code is much easier to administer. And of course, this is all written out right here. I pre-wrote it, but I didn't pull it into the video. So with your automobile, if you want to define a car, you can inherit that information from the legal definition of automobile. A car is defined by an automobile as defined by statute XX, article YY, section ZZ, using 4 wheels. And it just makes things really clean and easy for the lawyers and legislators to actually work with. Again, this is expressed. This has an exact parallel in coding, and these are called superclasses. And I'll pull this over, and we can see init superclass automobile. Actually, I don't know if you'd necessarily use init because I think that's initializing a new object, and superclasses aren't always, actually usually they're not used at all to create objects within software, but they actually define a lot of the different things within the video game. And you can see here exactly the same as the legal definition. The only thing that's different is that for cars, right here we have minimum variable seats, minimum of 1. Up at the top we have a minimum of 2, driver and passenger. And then for the number of wheels, that is not included in our definition of automobile for the video game. And now you can pull in for a car. You can do the exact same thing you do with the law, which is initialize a class, car, inherit, superclass automobile. So you're inheriting all of the information from up here. It's already defined somewhere else in the code. And then you have 4 wheels. And then if you wanted to create a motorcycle in the video game, then it's extremely simple. You just inherit everything from the superclass, and it goes down to the motorcycle. And you can even go down into something like if you wanted to have an 18-wheeler in the video game, and you have constant wheels 18, and you could define all kinds of stuff, how many hit points it has, especially important for something like the GTA games. It's all clean, it's all really well defined and easy for the developers to manage, and it applies to both software and to coding. So hopefully you can see the overlap between coding and law because of the way that both of them handle Aristotelian objects. They make things much, much easier to work with. One of the things, though, is that if you want to modify a definition, you have to actually understand what the definitions are and what the exemptions are at certain points, because you might strike certain information from a superclass. So if you had something like in a video game, so you had hit points equals 1,000, but you have a certain boss car that is invincible that you just have to chase through the video game, then you would need to create a way to strike this from the subclass or from the class lower in the hierarchy to make the code still relatively easy to manage. You can do that type of thing, but you have to understand where all of these changes are. Even though it's much simpler because there's much, much less code, if you start overriding all kinds of different stuff, it could start to make the code become something more like spaghetti code. And this is really, really common in law, where the statutes start to become so complicated that almost no one can navigate it. And again, if you wanted to, if something weird came out, like legally if they had cars that now could walk on legs instead of driving on wheels, that could create a whole situation where they have to go back and rewrite the statute. And a lot of times what the legislatures will do is they will go through and just ad hoc insert legs into a weird part of the legislation instead of reconsidering things as a whole. This also happens within coding. The advantage, of course, of a software project is that if it gets too spaghettified, it might just fail and get replaced by a different program. Whereas the law, we have to actually go back and rewrite the whole thing, which is extremely frustrating sometimes. And that's why it's really important to keep things as organized as possible, to understand the things that are being modified. But if you wanted to code and you didn't want to learn a computer language, there is another profession you can go into. You can become a lawyer, which I would think is a little bit more challenging than software development. And I'm not even a skilled developer. I just know a little bit, enough to get myself into trouble. And this all gets back into talking about spaghetti code and spaghetti law. It's something that Luke Smith talked about in one of his Not Related podcasts, where he said that the way that the ancients viewed law wasn't something to be written, but something to be discovered. So something that was inherent within reality. And if you look at objects, if you look at, say, Aristotle's chair, a tree stump can be a chair, a three-legged stool can be a chair, a four-legged stool can be a chair. These objects have emergent properties from the ground up, and things that are defined from the top down tend to follow a more Platonistic perspective, and the way that we've kind of separated those in our general philosophy is the things that are Platonistic in nature, the ideals, are defined through divine perspective, and then the things that are emergent are things that we have control over. They're more Aristotelian in nature in the world. This is all really important as we go into some of the other topics in the channel, things like right to repair and where certain issues come up in software and technology. This, of course, is a dedicated technology channel, so we're not going to dive too deep into the weeds all the time, but there is a lot of overlap between legal theory and software development theory, and making sure that these things all kind of match and mesh together. This is kind of an important video. I hope you learned something today. If you liked what you saw here, please consider checking me out over on one of the other platforms. I'll have a comment pinned down below for that. Thanks for stopping by. This is Nick, signing out.